Hello there! Welcome to AWS Service Spotlight. My name is Musa Khalid and I'm a training architect with ACG. And in this episode, we'll be shining the light for better or for worse on Amazon IVS or Interactive Video Service, where sane minds prevailed for once and gave this service a half-decent name. In this AWS Spotlight, we'll be dissecting Amazon IVS, seeing what it's good for and when to use it, what it costs, and some of its features. Yours truly will also be taking you through a demo of this service. Well, that's if Amazon hasn't changed the whole console UI on me again, in which case I might end this video abruptly and resort to hitting my head against a wall until it all works again. With COVID-19 causing much ruckus for in-person events and everyone flocking to social media to get their online presence felt, IVS is a service that's truly been built with ease of setup in mind. It's a managed, live streaming service that allows customizations and integrations using SDKs, which means you can create your own streaming platforms without worrying about end-to-end delivery of streaming content. And you can even make it interactive using its provided features. You'll also be able to use its API endpoint and calls through the AWS CLI. So how did this service come about? Well, if you've heard of this streaming platform called Twitch, you'll immediately be able to notice that IVS is a chunk of Twitch that's been made customizable and accessible to users globally. According to IVS GM Martin Hess, AWS has bundled together the powers of the Twitch platform and created a service out of it. They claim it works as well as Twitch, and if you're happy with Twitch, you'll be happy using IVS. So if you have something against the Twitch platform, you're the best off mowing your lawn while I drone on about this service a little bit more. So let's dive a little deeper into the working of this service. Video ingestion and distribution runs over Amazon IVS's Content Delivery Network or CDN. IVS works through channels, which configure how you want the service to stream your video to global audiences. There are two channel types. A standard channel, which includes transcoding your incoming stream to multiple resolutions such as 1080p, 720p, and 480p, and also allows for full HD video streaming. The second channel type, a basic channel, doesn't offer any transcoding and only provides 480p resolution streaming, which one may use for non-real-time streaming. Part of a channel is an ingest server, managed and maintained by AWS, which you will point your stream towards. You'll get back an ingest server URL, a stream key, and a playback URL. You'll simply need to plug the ingest server URL and stream key into your streaming software, and that's all you need to do from a setup perspective. So far, examples of streaming software that AWS cites in their documentation for IVS and which I've tested are OBS and FFmpeg, which are both available to download freely and available on most operating systems. Another interesting feature of Amazon IVS, which enables interaction during live streams, is timed metadata. We'll witness it in our demo later on. Using API calls, you can inject metadata such as quizzes, questions, and polls and increase engagement on your live streams. Finally, you can make your streams accessible to authorized viewers using private channel. You can either create or import a playback key, which is ECDSA, and enable authorization in your IVS channel. One of the features that's really going to come in handy and help automate your live streaming will be IVS's integration with Amazon Event Bridge. This allows you to monitor your stream in real time and take action on events such as a stream stopping, starting, or breaching certain limits. Of course, no service is ready for general availability on AWS unless it has its blessing from Amazon CloudWatch, and so you can find useful metrics populated for tracking your IVS usage on CloudWatch. Like all AWS services, IVS has its limits, otherwise known as service quotas. A notable one being concurrent viewers. This is the maximum number of viewers allowed to stream a live channel across all AWS regions, and its limit is 3000. The ingest bitrate for standard and basic channel types is 8.5 and 1.5 megabits per second respectively. If you exceed these limits, your stream may be terminated. Now let's talk about a little thing called security. Amazon IVS encrypts data in transit using HTTPS API endpoints, RTMPS for ingestion, and HTTPS for playback. No configuration is required for API endpoints. For ingestion, streamers can secure their content by using RTMPS. This is a default requirement, by the way. For transcoding, data may be transmitted unencrypted on internal Amazon networks. For playback, data is served over HTTPS. Live video content is not stored and is ephemeral. It simply travels through the system and is cached on internal systems while being viewed. Exciting stuff, right? Now let's talk about how much moolah you might need to spend for using this service. There's no upfront commitments required to use Amazon IVS, and customers pay only for the duration of video input to IVS and the duration of video output delivered to viewers. AWS is offering a free tier to new customers for the first 12 months with 5 hours of basic channel stream input and 100 hours of basic channel stream output. For on-demand usage, a standard input stream to AWS will cost you $2 an hour and basic stream will cost you $0.2 an hour, whereas output streams will vary depending on the regions where your viewers are. Now let's work out our pricing example for Amazon IVS. Let's say that you streamed a 2-hour event with standard channel type streaming up to 1080p to 200 viewers from the US, with 100 viewers watching in SD, 50 watching in HD, and 50 viewers watching in full HD. Let's break it down. The input stream cost is going to be $2 an hour multiplied with the number of hours, which is 2, bringing us to a total of $4. The output stream to viewers is going to vary by the region the viewer is in and the quality of content streamed out to the viewer. So, SD output stream to US viewers will cost $0.0375 an hour multiplied by 2, the number of hours, multiplied with 100, which is the number of viewers, brings us to a total of $7.50. HD output stream to US viewers will cost $0.075 an hour multiplied by 2, the number of hours, and then by 50, the number of viewers, bringing us to a total of $7.50. Full HD output stream to US viewers will cost you $0.15 an hour multiplied by 2, the number of hours, and then by 50, the number of viewers, for a total of $15. Adding it all up brings us to a total of $34, which is the cost of this event, and this is a little example of Amazon IVS pricing. Enough talking though. Now let's walk the walk and look at a demo of this service for real. So I'm logged into the ever-changing AWS console. Hopefully it doesn't change on me while I'm working on it. We're going to head towards the services console and look for media. And under media, we'll be clicking on Amazon Interactive Video Service. We're going to create a channel, which is basically what defines the configuration for what you're going to stream. And it is pretty simple. You're going to either choose a default configuration, which uses the best standard channel type for you, and the best video latency, which is ultra low, and has the playback authorization disabled. Or you can go ahead and customize the configuration by changing the channel type and the video latency as per your needs. We'll give our channel a name, and we'll go ahead and click on Create Channel. And that's it. That's how easy it is to create an IVS channel. So let's look at what data is returned to us. We have been returned with an ARN for this channel. We've been returned with an ingest server to which we'll be pointing our streams towards, and a stream key, which is hidden for right now, but we'll be using this to connect to our ingest server. And we've been also returned a playback configuration, which includes the playback URL that we can embed in our front-end web pages so that our ingest server streams out towards this playback URL wherever it might be embedded. On this page, we also have a live stream option. So if and when this channel is live, it can show you a sample of the stream that is going out to the viewers globally. For right now, we'll go ahead and set up our streaming software. Amazon has set up a documentation page which shows you what streaming softwares are currently available and can be used. The first one is the OBS Studio software, which is freely available. And the guide to follow along to download and set it up is shown here as well. I've already downloaded this OBS Studio software onto my MacBook. So I'll go ahead and set up the OBS Studio software to stream out towards the ingest server. So let me bring up the window. Right now, I'm sharing one of my screens on which you'll be seeing a quick shell command, which is going to loop through some numbers so that we can stream it out to the IVS channel and see it being displayed globally to all the viewers. So the first step is to go into the preferences of OBS, click on stream, And this is where we're going to be embedding the values that the AWS console has given back to us. So we'll head back. We'll grab the ingest server, paste it in here. And next up, we'll be pasting the stream key, for which we'll go back and do the same thing again. We'll leave all of the values to default and we'll click on OK. All we need to do now is to click on Start Streaming. And once it connects, if you head back to the console for IVS, you'll be able to click on the play button on the console. And in a few seconds, the stream is going to be live. So if I go back to my actual screen, which is being streamed, and hit enter, there's going to be about a 5-second delay as per Amazon, which was lesser than what they claim actually, which is pretty nice. And you'll notice that my system's screen is being streamed out to IVS, and this is the sample of what the global viewers would see. Right now, this is just a sample. I can go ahead and embed this playback URL into any front end that I want to play it in and customize it to my liking. So let's go ahead now and do that. To stream to viewers globally, you'll need to utilize the SDK for IVS Player provided by Amazon and embed the playback URL that IVS channel has returned to you inside your application. So we'll copy over the playback URL and have a look at the sample code provided on the documentation page for IVS Web SDK for IVS Player. So I've already taken the liberty to set up an Apache web server hosted inside a container on my local machine, which hosts this web page with this code snippet. So let's head over to the Apache web server set up on my local system. And we'll open up the index.html file, which is where I have pasted the code. And all we need to do is to replace the dummy placeholder with the actual playback URL. And we're all set to go. So we'll save and quit, and I'll head over to a browser, open a new window, and type in the URL for my web page. And though this is a very minimal setup, but you'll notice that the stream, which I am streaming globally now, that is ingested by the IVS service and has been spit out and used in the playback URL to play to a user, which is represented by this Apache web server page. So this is a quick little example of how to use your own custom interfaces to embed the output stream to users globally. Now let's look at a more elaborate example of how to use a nice feature within IVS known as timed metadata. This feature can be used to inject useful questions, quizzes, or data inside your streams in real time to get real information and feedback from your viewers. For this example though, I want to use some other streaming software. So I'll be shutting down the OBS stream and using another method also shown on the Amazon documentation for streaming software, which can be used with Amazon IVS. So let me shut down OBS. And if we head to the documentation for streaming softwares and scroll down, we have another option called FFmpeg, which is a multimedia framework that can also stream out to IVS. So the method to set it up is here, and I'll try to follow this. For this, we'll be heading down to our trusty command line and trying to build the command to stream out to our Amazon IVS channel. Before we do that, the command requires us to set up a few variables on the command line, which are going to be needed by the FFmpeg command to stream out to our Amazon IVS channel. The first of those variables will be stream_key. Next up, we'll be creating an ingest_endpoint variable. This variable basically is the ingest endpoint which the channel returned to us, but without the RTMP or the port appended to it. And finally, we'll be providing it a path to the recorded video that we want to stream. For that, we'll be using the variable video_file path, and this file is currently in the same directory in which I'm right now, so we'll hit enter. And now, all we need to do is to execute the command as shown on the documentation page. So the command is basically quite elaborate, and you don't need to understand all the variables inside it. You can simply copy paste it from the documentation, the link for which will be under this video. You'll notice that the variables which I just created are embedded in this command, video_file path, ingest_endpoint, and stream_key. So I'll go ahead and hit enter. And FFmpeg is going to start streaming out this video to the IVS ingest server, and now it can be viewed globally. To show you an elaborate example of the timed_metadata feature, I've actually utilized a very nicely written blog on Amazon Media Blogs. This blog basically has you set up a sample demo of the timed metadata feature. However, I've only used the front-end code from this sample and embedded it inside the same Apache web server that I showed you earlier. So this code is also available on their GitHub, and the link to it will be provided in the description or in the resources of this video. So we'll head over to our Apache server, and I've already created a file called index2.html in which I've copy pasted the code provided through the blog. And all that we need to change in this code is the playback URL. The real thing which matters here is the URL and the code for ingesting the timed metadata, which you don't need to worry about. This is just to show you how easy it is to get started with the sample that Amazon has provided. So we'll paste in the playback URL. I'll quickly head back to our console and copy over the playback URL one last time. I'll paste it inside my code, and we're all good to go. So to test it out quickly, we'll head over to a browser, open up a new window, and type in the URL for our new web page. So you see how neat the UI is. And if I was to start streaming, this is the recorded video that I'm streaming right now. Now let's go ahead and inject some timed metadata into this live stream. The beauty of it is that we'll be using an AWS IVS API call and sending our metadata to an IVS endpoint, and we don't have to care about interacting with the front-end web page or any other backend ourselves. IVS takes care of it all. So we'll head over to our command line, and let's start typing out the command. The command would be AWS IVS put metadata. This is the API call against the IVS endpoint. We'll need to provide it a channel ARN for the channel that we created. So let's quickly go and grab that from the AWS console. We'll paste it in. And finally, we need to provide it the actual metadata that we need to pass as a feedback or a quiz or whatever we want it to be. So the flag for that is ---- metadata. And the metadata is usually passed as a JSON structured string. I've got a pre-built example from the blog that I mentioned, so I'll paste it in. And you'll notice that we are basically asking a question from the viewers, which is here. The question itself is, are cats awesome? And then we have provided them with some options. So once I hit enter, IVS will inject this inside the stream and show it to all the viewers viewing the stream at that moment. So let's go ahead and hit enter and head over to the IVS stream. And here it is. Our timed metadata has been injected inside our stream, and now all the viewers have an option of choosing their best answer to this question, which is obviously going to be true. And this is not the end of it. Think about the possibilities that this feature opens up for making your live streams more interactive. For example, you could ask users in real time about a product being advertised or something that you're talking about. You could then store the answers for analysis later. This demo was just to show you how easy it is to get started with Amazon IVS without worrying about end-to-end infrastructure that is required for such a task. And of course, the answer to the poll question being asked here is going to be true. I mean, cats are kind of awesome. Should you invest, evaluate, or revisit? My recommendation is to evaluate. I've got to be honest here. This service has grown on me and I quite like it. I mean, my friends wouldn't exactly call me a front-end developer, but look how easily I created a customized low-latency video streaming webpage. The internet wasn't designed for live video. Live video was shoehorned into the internet, and this service makes it seamless to stream globally within hours, if not minutes, with the added bonus of being in control of how it integrates into your applications. I think that this service really enables developers and even non-developers to build customizable streaming experiences quickly. The off-the-shelf working time for this service is surprisingly very quick. I wouldn't invest heavily in this service though, without a solid need, as this is not meant to provide services to rival Netflix and similar platforms. However, it's awesome if you are looking to provide a customized, interactive streaming platform without worrying about the overhead of developing ingestion, transcoding, and global content delivery plans. So that's it. This is the service overview of Amazon IVS. Keeping awesome, Cloud Gurus, and I hope to catch you again in another AWS Service Spotlight. This is Musa Khalid for A Cloud Guru.